Welcome back to 7.6, vertex form of a quadratic equation. Let's begin. Up to now, we have two main equations we've been working with. We've had the standard equation, which is y equals ax squared plus bx plus c. And we have the factored form of the equation, which is y equals a, x minus r, and x minus s. Today you're going to get the third formula, which is the vertex form. Okay? This formula is y equals a times x minus h squared plus k. As I mentioned before, these formulas will be available to you during quizzes or exams, but you have to know how they work. When you are dealing with the vertex form, two important things. The vertex, the reason it's called the vertex form, the vertex is h and k. Okay? So the value of h and the value of k are very important as they tell you what the vertex is. Obviously, h is also the line of symmetry as well. And the a remains the same as it has in previous formulas. If a is positive, the graph opens up, and if a is negative, the graph opens down. So let's take a look at how this formula works in practice here. Your formula is y equals negative 2 times x plus 4 squared plus 10. I'm going to write down the vertex form again, just so we can refer to it. Okay. We have to sketch the graph and we have to state the domain and the range. Okay. Step 1 is to find the vertex. Okay. We know the vertex is h and k. Now the thing with h is, you see that the formula is x minus h. So when you look at this value here for the x value of the vertex, it's actually the opposite of what it looks like because of the negative sign, right? So the actual value, x value of the vertex is negative 4. And the y value, in the formula it's plus k, so the k value is always exactly the same as it looks. So the h is opposite of what it appears, and the k is the same. So the vertex is negative 4 and 10. Okay, so if we were to graph this, we can't yet, but we can get started. Put our graph over here. Our vertex is at negative 4 and 10. Right here. Okay. We see the a value is negative, so this graph is going to open down. In order to graph it, we need to find two more points on the graph, okay? Step 2 is to find the y-intercept. So to find the y-intercept of this graph, we're going to make x equal 0, and we're going to solve for y. So to find the y-intercept, we make x equal 0. So y equals negative 2 times 0 plus 4 squared plus 10. 0 plus 4 is 4. 4 squared is 16. Negative 2 times 16 plus 10. Negative 2 times 16 is negative 32. Plus 10 is negative 22. Okay?
How did you get x equals 0?
To find the y-intercept, you just make x equal 0.
You just would put it different.
Yeah, because if you're thinking about where the y-intercept is, which is like down here at negative 22, right? What's the x value of this coordinate? It's 0, right? So anytime you have the y-intercept, the x has to be 0 because it's on the y-axis. So to find the y-intercept, you always just make x equal to 0. So now we've got our y-intercept, which is at 0 and negative 22. The final step is to find how do we want to say this? We're going to find another value equal distance from the axis. Okay, so here's what I mean. We know the parabolas are always equal, right? So we've got half of the parabola. Oops. Try to draw this better. We have half of the parabola right here. Okay? So what we have to do is we have to find the mirror image of this point on the other side. So what we do is we look at our x values, okay? The middle of this parabola is at negative 4. This point here is at 0. So these x values are 4 apart, right? From 0 to negative 4, there's 4 squares in between. So then for this parabola to be equal, there also has to be 4 right here. 4 apart here as well. We're just finding the mirror image. So our second point is going to be at negative 8 and 22, because we know that the axis has to be exactly in the middle, right? So if the axis is in the middle, you have half the graph on this side and half the graph on the other side. So once we have the y-intercept, we just put the mirror image on the other side.
How did you find out that there's 4 apart?
Well, because I just looked at the x values. The x value in here, right? The middle is negative 4. This one here at the y-intercept is 0. So to get from 0 to negative 4 is 4 steps, right? Negative 1, negative 2, negative 3, negative 4. Then we just have to go 4 more steps to find the mirror image on the other side. You'll see, we're going to do another example in a minute, and you'll get another chance to practice that. And then we're done, okay? We've got our graph. So once again, you find the vertex, you find the y-intercept, you put the other dot equal distance apart, connect your dots, and you're done. The final thing it wanted was the domain and the range. Okay, the domain is XER, as it basically always is, as the graph extends forever and contains all x values. The range, the highest y value is 10. The lowest y value is negative infinity. So the range is y is less than or equal to 10. Okay, let's try another one. So here you've got y equals, and sometimes they use f of x, which means the same thing as y. Y equals 2 times x minus 3 squared minus 4. Okay, I'll write that vertex form on here again, just in case you needed to see it. Once again, step 1, find the vertex, which is, remember the h is opposite, so it's 3 and negative 4. Once you have the vertex, you're going to find the y-intercept by making x equal to 0. I'll do that up here. So I put a 0 in for x, 0 minus 3 squared minus 4. 0 minus 3 is negative 3. Negative 3 squared is positive 9. 2 times 9 minus 4 is 18 minus 4 is 14. Okay. So the y-intercepts, let's sketch a graph over here. The vertex is at 3 and negative 4. The y-intercept is at 0 and 14. Now, to find the other point, we have to look at how far apart are our x values. And how far apart are 0 and 3? They're 3 apart. Okay, so then we go over here. If we went from 0 to 3, which was 3 apart, we're going to go from 3 to 6. Put our dot there. At 6 and 14. Connect our dots. And we're done. Okay. 7.6 is one of the easier sections of Chapter 7 because you don't have to do any factoring, right? Some of the hard stuff is the factoring in 7.4 and 7.5. But here, the only real work you do is putting the 0 in for x and solving for y. The equation kind of gives you everything else. I believe there's one more. Oh yeah, we gotta talk about this. Okay. The next thing is how to predict the number of zeros. And zeros is the same thing as x-intercepts. Sometimes they call them zeros and sometimes they call them roots. I try to call them x-intercepts all the time so it's consistent. So what we want to look at is how to predict the number of x-intercepts in a quadratic function. So you could get a question like this on your quiz and they could ask you, how many x-intercepts are there? 0, 1, or 2? And then you'll have to answer it. So let's go through each of them so you can see how it looks. The first one says f of x equals 2 times x minus 2 squared minus 5. So find the vertex is at 2 and negative 5. 2 and negative 5. Then ask yourself, which direction does this open? Does this parabola open up or down? Well, the a is positive, so this opens up. So if the vertex is below the x-axis and it opens up, how many x-intercepts is this graph going to have? Excuse me? How many x-intercepts does it have? 2. One here and one here. So if the graph opens below the x-intercept or the x-axis and it opens up, it has 2. At the same time, if the vertex was up here and the a was negative and the graph opened down, how many x-intercepts would that have? 2. Okay. Next example. It says f of x equals negative 0, x minus 0 squared plus 0. Step 1 is to find the vertex, which in this case is at 0 and 0. If the x-intercept is right here, if the vertex is at 0 and 0, this graph opens up. How many x-intercepts does it have? How many times does this parabola touch the x-axis? 1. Right there. Okay? If it opened down and the vertex was at 0 and 0, how many x-intercepts would it have? 1. Right? It only touches the x-axis one time. Okay, last one. F of x equals 2 times x plus 3 squared plus 4. So our vertex is negative 3 and 4. Negative 3 and 4 is right here. And this graph opens up. How many x-intercepts does this have? No. 0, right? The vertex is above the x-axis, and the graph opens up. It actually has 0 x-intercepts. Same thing, if the vertex was below and the graph opened down, how many x-intercepts would that have? 0, okay? So anytime they give you an equation, like let's say they gave you f of x equals negative 4 times x minus 1 squared plus 3, and they ask you how many zeros, find your vertex, which is 1 and 3. And then I would probably just sketch a quick graph just so I didn't make any mistakes. Vertex is at 1 and 3. A is negative, so that means it's going to open down. And now I can tell how many x-intercepts it has, right? So that's the best way to do those types of questions.
Wait, why did it go down?
Because the A is negative. If this first number is negative, it always opens down. If it's positive, it always opens up.
Oh.
So you plot the vertex and then look at that A value.
Oh, I thought it was the X.
No, no, it's always right here, whatever this is. Okay? Okay. We did that one already. All right, that brings us to the end. You're going to get some time to work. It's not a incredibly long section. So the workbook questions are page 199, 1 to 3, and 8 to 10. Let's work on this because we are going to be writing a 7.4 to 7.6 quiz today. Thank you. Have a good day.